Now let's see what will happen in case if you are using next fit. See what is meant by next fit. Next fit works exactly like first fit, but there is a small difference. After allocating a process, we will start from the place where we left out, okay, rather than starting from the first. Let's see this. Whenever a 300 KB process comes into the RAM, what we will be doing is we will be scanning from the beginning, and once we find the space, we will occupy it. Now we have a space of 50 KB, right? Now whenever a process of size 25 KB comes into the RAM, again what we will do is we will not start from the beginning, right? This is because this is next fit, and so we will start it from here, and so this 25 KB will also be allocated, okay? Right now we have a total space of 25 KB here and 150 KB over here. Now whenever a process of size 125 KB comes into the RAM, what we will do is we will start from here, since we are not able to occupy 125 here, and so we will go here and then we will start again from here. Once we find this hole, we will occupy this 125 over here, okay? And so we have a space of 25 over here and 25 over here. Now whenever a process of size 50 KB comes into the RAM, again it leads to external fragmentation, right? Which means I cannot allocate this 50 KB process over here because they are not present in contiguous allocation. The holes are not present in contiguous addresses. And so using next fit over here actually leads to external fragmentation. Now let's see what will happen in case if you use worst fit, okay? See what is meant by worst fit. We will scan the complete RAM and then we will find out the largest hole which is big enough to hold the process, and then we will allocate the process, right? Fine. Now we have 300 KB. Whenever 300 KB request comes to the RAM, we will scan the complete RAM, and 350 KB is the largest hole which is big enough to hold the process, and so we have allocated this 300 over here, okay? So right now we have 50 KB of free space over here and 150 over here. Now whenever a 25 KB process comes into the RAM, what we will do? We will scan the complete RAM. We will find out two holes, 50 and 150, which can hold our process. Out of this, the biggest hole is nothing but 150, and so we will allocate this 25 over here, okay? 25 over here, and so we are left with a space of 125. We have two holes now, 125 and 50. Now whenever a process of size 125 KB comes to the RAM, again what we will do is we will scan the complete RAM and then we will occupy this 125 over here, okay? So right now we have a total of 50 KB hole, right? Only one hole and of size 50 KB. Now whenever this 50 KB process comes into the RAM, again we will place this 50 KB over here. And so right now we don't have any holes, but we have allocated all the processes, right? Which means we have satisfied all the requests. And so worst case works perfectly fine here. See, coming to now from this, can we say that first fit and worst fit are the best algorithms? No, we cannot say like that. Because of this ordering, we are able to find out that first fit and worst fit are working fine. But in case if we change the order, so what might happen is best fit and next fit might work fine, whereas first fit and worst fit might not work fine. See, anything is possible, right? Coming to this example, worst fit and best fit are the best algorithms, okay?